Well, everybody, welcome back. We're going to get started on our second part here with our keynote from Mick Patterson of Facades Tectonics. So it gives me great pleasure to introduce Mick Patterson. Mick is a designer, researcher, educator, futurist, author, photographer, and entrepreneur. He has concentrated his professional and academic career on advanced facade technology and sustainable building practices. He pioneered the introduction of structural glass facade technology in the US in the 1990s, implementing diverse and novel applications, including cables, trusses, cable nets, and grid shells. More currently, he is the founder of Facades Tectonic Institute and serves on the steering committee and is co-founder of the Facades Plus conference series. Mick has been a longtime supporter of ACAW and I think was present for our second ACAW. He has continued to be an inspiration for us in terms of what we're trying to do and achieve in the workshop. And with that, I'm very pleased to have Mick Patterson join us again. Please join me in welcoming him.
Hello, Omar. Hello, everybody. Can you hear me, Omar?
I can hear you fine. You can go ahead and share your screen as you like.
Okay, good. I am going to. All right, here we go. Can you share my? Can you see my screen?
All's good.
Okay, great. So just a clarification, I'm not the president of the Facades Tectonic Institute. Helen Sanders is our current president. I am currently the ambassador of innovation and collaboration, and very happy to be here. So we're going to talk some trash today. We're going to talk some trash about buildings and their facade systems. We're going to talk about one of my favorite topics, which is it'll be interesting to talk to a bunch of innovators, such evident innovators as represented by the presentations that I've seen so far. Amazing stuff. Talk about the drivers of innovation, a little bit about facade material and process trends, facade design trends, emerging collaborations, collaborative project delivery strategies, embodied carbon. There's lots to talk about. I'm kind of hung up contextually on this ongoing climate catastrophe. I have a difficult time getting beyond this, and the most recent report, which, the UN Secretary General called a code red for humanity. It didn't really have, if you haven't had a chance to take a look at it, didn't have a whole lot of really new revelations in it. But it does compress the time frame. This thing is happening faster than the scientists anticipated, and it's a big deal. So we all got wrapped up in this, in the pandemic, of course, and I know that myself and others that I've talked to kind of sort of paid a little bit less attention to what was going on with carbon. We made the assumption that with the global economic shutdown, that we had to have at least something of a drop off in carbon emissions. And the good news is that we did, in fact, but the bad news is that it was not much. And in fact, the IPCC has already stated, that we need to reduce carbon emissions by about 7.5% each year over the next decade to keep global temperature rise down under 1.5% C. And in fact, last year, with an global economic shutdown, our reductions did not reach that 7.5 level. So, this is very alarming and concerning. And in addition to that, according to the NOAA, the ppm of carbon actually increased during the pandemic. And you can see that, it went from 2019 to 2020, it increased to 414.49 ppm. The executive director of the IEA had this to say about carbon emissions. And so there's a lot of red flags going up, a lot of concern, and not a lot of change going on. One of the interesting things that that there's these constant revelations, discoveries in things that we're doing wrong in buildings, embodied carbon being one of those things that, is relatively recent, emerging in the dialogue, particularly over the last 5 years. Another one of these things is thermal resilience. And my friend Ted Kessick at the University of Toronto just was involved in the release of this thermal resilience design guide, which I think is really quite interesting, especially in the context of, the wildfires that we have going on out here in the West Coast. I'm in Los Angeles. But, these concepts of thermal autonomy, passive habitability, and fire resistance are super relevant right now when we're seeing what we think are potentially the most devastating impacts of climate change in the form of these increasingly threatening heat waves. And we had, temperatures approaching 120 degrees in Portland, Oregon this year. And, consequently, I'm having to think a lot about, I find myself thinking a lot about the ethics of what we're doing, what we're about. And there's this concept of non-maleficence, which is basically an ethical obligation not to harm anyone, right? Which manifests in the Latin phrase that translates as "first do no harm," which we're all familiar with. Has been picked up largely by the medical profession. We are builders of buildings. This is our industry, and our buildings are problematic. In fact, they're killing us both directly and indirectly. We all are aware of the fact that they are that buildings contribute close to 40% of the carbon emissions that are such a problem. And this concept of passive survivability in buildings, what happens when the power goes off and you've got a substandard facade system in place, and in a very, very short amount of time, people are in trouble in these kind of dramatic climate events that are increasingly taking place. So, I'm rooting for disruptive transformation. We have to go through a transformation in the built environment. So what does skins have to do with all of this? What's the relevance of the building facade when it comes to, these kind of considerations? So, just a very brief introduction to what I call the facade zone. It's interesting, right? There's really nothing in architecture that combines attributes of both performance and appearance as does the building skin. And the building skin is the nexus of these myriad, as I note here, often competing performance considerations. And what I mean by that, this is a couple of handfuls of these considerations here, by no means exhaustive, but I think it's really indicative of the uniqueness of the facade system in buildings. And you have considerations like daylighting and glare, which can be in opposition of each other and have to be balanced. Many of these things, in fact, have to be balanced to achieve a fully integrative and optimal outcome in facade design. It's very challenging. This is another graph of a graphic representation of some of the considerations, some of the strategies, sort of a layer of the onion graphic, if you will. And at the center is occupant health and comfort. And, this is another one of these things that emerged relatively recently in the dialogue, this sort of broad recognition that that this is what buildings are for, is for the occupants, for the health and comfort of the occupants. And we can't be looking solely at energy consumption and this kind of thing. In fact, we spend, according to the EPA, pre-pandemic, 90% of our time indoors. So the indoor environmental quality obviously is of great relevance, and the facade system has a huge impact on that indoor environmental quality. And post-pandemic, I'm sure that it's been significantly more than 90% of the time that we spend indoors. From the standpoint of energy consumption, you don't have to go any further than the Department of Energy's statistics to see that in energy consumption in buildings, the facade system has a huge impact, affecting more than 50% of that energy consumption. And as an industry, we've developed a number of strategies and technologies to deal with these kind of things, ranging from the facade systems themselves to material types, glass types, and integration with shading systems and sensors and controls and this kind of thing on the interior. So, I was at an event a while back. Bjarke Ingels with Big Architects was a keynote speaker. And he made a statement that I thought was striking. He said, sustainability is a design problem. And I really hadn't thought about that, but it certainly is, right? Sustainability and resilience both are design problems, which puts us as designers in the driver's seat in terms of solving these problems. And in what this is about really is about innovation, right? And so thus, we're going to talk a little bit about that today, but I'm talking to a bunch of innovators already, obviously. We must innovate our way to resilience and sustainability in the built environment. To get from where we are to where we need to go requires massive innovation, right? But how well do we understand what innovation is? And I talk to a lot of people. I oftentimes am not talking to a group like this, which is largely a group of innovators. I talk with a lot of industry people, and even ourselves as creatives. It's like we've polluted the language, right? I mean, a lot of the words that we use, a lot of the things that we talk about, words like sustainability, resilience, high performance, innovation, we think we're communicating with each other, but when you really strip it back, like words like sustainability, it's kind of like talking about God, right? You can talk about it, but while you're doing it, everybody that you're talking with has a different idea in their mind of what that really is, what it represents. And we've sort of failed to converge on clean definitions for these things. And it's really compromised our ability to communicate about these things, right? So, what really is innovation about? What is at the root of it? And it's not an easy answer. One of the things, that resonates with me and drives my interest in innovation is innovation as a change agent. I see the potential of innovation as bringing the kind of change that we need to transform the built environment, right? So, Bucky Fuller, one of my favorite guys, this is one of my favorite quotes of many of his. The reality is that the current need lies well beyond incremental change, and we are basically mired in incremental change. And somebody somebody in one of the presentations earlier talked about how the firm really like to embrace the constraints, and that resonated with me too. Embracing the constraints drive change. Constraints drive change. We do everything we can in society to avoid the constraints, right? Because everything is driven by vested interests, and it's all about protecting those vested interests, which, all of that is about pushing off the constraints. We really need to embrace these constraints, and we need to bring on the disruption, right? I mean, we've seen a lot of disruption. We've seen the disruption that the internet and digital technologies have brought, to essentially entrenched industries at the time, ranging from, the telephone to the broom. What is going to be the disruption of buildings? What's that going to look like? What does it even mean? And what does it mean to try and bring this in an industry that is as risk averse as ours, right? I mean, this presents a significant barrier to implementation. You know, it's a risk averse industry, and the industry, the business owners equate innovation with risk, right? So the last thing they want to do is in most cases is they don't want to know about what we can do that is, you know, really innovative for them. They want to know what we can do for the lowest price and how many times we've done it in the past. And the more times that we've done it and the longer we've been doing it, the better they like it, right? So it makes it very difficult. We have to convince them that we can manage the process of innovation in a manner to mitigate risk. And, you know, for our own sake, we have to develop the craft of innovation, which I have seen, and I'm so impressed with, you know, the ACAW and the work that Boston Valley Terracotta and these teams have been doing in this direction. I think it is very important, and I'll talk a little bit more about that as we work through this. But what we're really involved with here is implementing innovative building technology, and it's a challenge. It's not just about, so when I go out and I'm talking with people, like I'll be talking with the glass industry people, and you know, I can tell that when I'm talking about innovation, they don't think I'm talking about them. They think I'm talking about the designer, right? At the computer, you know, working through the design stuff. And, you know, what we need to be doing is innovating at every step through the process of building. And so it involves processes, it involves practices. It, you know, it's, you know, when I was running my own company, I would tell everybody in the company, whether it was the receptionist or, you know, our engineering staff or whatever, that everybody's a designer. And that was the expectation. So a big part of this, and a big part of what we've seen from the teams today, is collaboration. And one of the most innovative areas actually in building design and delivery these days are novel collaborative delivery strategies that are emerging and are really important for the potential of this transformation in the built environment. And these are represented by Design Assist, which I'm sure many of you have heard of, and probably many of you have participated in. This is another one of these terms that you know, there is no clear definition that we've converged on, right? And so, you know, depending on who you talk to, it'll range from true collaboration to, you know, to getting, involving expertise as early as possible in the design of, you know, in the design phase of a project, and getting them to do as much work as possible for free as early on as possible. And that's what I call business as usual, not design assist. But you know, that's a whole other thing. And then there's this aspect, a really important aspect of market dynamics that's going on. And there's always this push-pull, right? And you've got industry that is pushing products that are ready for adoption, and they're not being adopted, right? And then, you know, conversely, you can have a market dynamic where the design community is begging for, asking for, pulling for new product innovations out of industry. And where we're at right now, I mean, it's been changing a lot. And, you know, these things, if you look at this historically, there have been long entrenched patterns, but lately these things have been changing, you know, much more frequently. But we're definitely in a situation now where it's a push. And what that means is that there are technologies, higher performing technologies, that are really important, that are not being adopted and used in buildings. And you know, part of this is because of a lack of codes, you know, that would necessitate their interest. And part of it is a lack of awareness and specification practices and this kind of thing, but it's a problem. The adoption of curtain wall technology in the 20th century took 30 years. I mean, you know, in the early 20th century, there were some really innovative curtain wall projects that were executed, implemented. The technology was there, demonstrated successfully, and it wasn't until into the 60s that the technology really took off. In sometimes not so great a form, but that was the time frame that it took off. So innovation is not something that is magic, like a lot of people look at, and a lot of you understand this, right? You really have to set the stage for innovation. You have to build the innovation machine. You got to put the dials in place. And once you've done that, you can innovate. You can innovate predictably, reliably, and in a manner that that manages the risk that goes along with innovation. This can look very different depending on the kind of organization that you are. For my own personal exercises, what this involved was putting together a multidisciplinary staff, right? A multidisciplinary team of collaborators, if you will. And we would do research, right? We integrated research with everything that we were doing. Every project that we did involved research. And that a key part of that was starting with the right questions, the best questions. We always took time for blue sky investigation. We always started with a blank sheet of paper. We made sure that we had the right tools for the job for all of our people, no matter what they were doing. And we spent the money, to have the right tools. We focused on processes that we characterized as rapid visualization. And this was at a time when 3D digital printing and this kind of thing were a novelty. And now we've got more interesting technologies like VR and these kind of things coming online. That's about having the right tools, the most progressive tools for the job. But this process of visualization is constantly morphing, constantly changing. And it's really important for us as innovators to stay on top of this, right? And then as you move to execution of these things, mock-ups and prototypes, you can't do enough mock-ups and prototypes. You can't do enough testing. This has to be an integral part of the process. This is key to mitigating, mitigating the risk that's associated with innovation. And really impressive to see some of the work today, especially I'm thinking of the HOK tri-pyramid Permis-Lisa Gartner collaboration with the terracotta mullion, and mind-boggling the design and the extent that project went to in terms of creating a mock-up and a full-scale mock-up, and really, really beautiful work. So, there are these things. So this stuff is, stuff that I pulled from a half-day or full-day innovation workshop that, that the Institute does. So there's not an opportunity here to get into this kind of thing. But, we've all heard this, reward failure, right? But how well do we execute there? How well do we do it? It's not easy to do. And again, it's a principle that's not well understood. It doesn't mean that we let people fail, make the same kind of mistakes over and over again, but carving out room to make these kind of failures and going after them and celebrating them and learning all that they have to teach us is hugely important. There's some shortcuts, right? I'm into shortcuts wherever I can find them. We need shortcuts now, right, to get to where we need to be in the built environment. Imitation is a great behavior, I think. And the trick is in selecting the source of imitation. So if we're going to imitate something, let's make sure it's the best thing that we can imitate. And then let's push the envelope of that and make it ours, own it, take it to the next level. And find the drivers of change, right? This is really important. And these are going to vary depending on the project and where you are, and many factors like that. But they can include things like fuel costs. We're all familiar with budget, performance requirements, sustainability. I mean, I've been around for a while, and I saw, I recognize the fact that we've been burdened in the U.S. by lax building codes and cheap energy prices. This goes back to, the energy crisis in the 70s, and seeing how, Europe, Germany in particular, respond to those with very significant aggressive performance requirements in buildings. I'm talking about reducing energy consumption in buildings by 80% over just a few years, and how that drove facade technology forward 20 years beyond what we had going on in the US, and we're still playing catch up in many respects. Digital processes are interesting, big part of what we're all involved with these days, and there's a lot of nuance to this too, right? I mean, I teach at USC. I see what I like to call the Rhino effect, right? Where the kids are given these tools and they can easily generate these wildly complex forms. We have to be aware of the complexity. Complexity is a sustainability consideration. We need to look for simplicity wherever we can. So, this complexity manifests more in different ways as we move closer to, the actual implementation and construction of a building. So they're not so easily fabricated and not so easily erected, some of these innovations. Digital processes have enabled what architect critic Peter Blake called wet dream architecture, and that's we're seeing the complexity impact. It's one of the biggest trends, right, in architecture today. Two big trends, that we all recognize: geometric complexity in the building skin, hugely amplified, and also materiality, right? The palette of materials in the building skin. It's not all aluminum glass anymore, right? These are two of the big changes. And of course, one of those materials, again, that is being investigated at ACAW so beautifully is, the terracotta thing. Complexity versus ingenuity. I mean, basically we are, I believe, as designers, obliged to consider the simplest solution to any given problem and to move from there. And I see evidence constantly of that, of skipping that. So, design trends that are ongoing, the exploration of thin skins versus deep skins. We saw some deep skin work today. I think of sort of like the work of morphosis and the layering of the facade system, to the point where sometimes it gets hard to tell where the actual barrier between indoors and outdoors is. And there's all kinds of functionality going on there, including the incorporation of public space sometimes in deep double skin structures, like the Shanghai Tower comes to mind, Gensler's project. And then thin skins. All the technologies getting packed into the most minimal area, that 1-inch IGU, and then squeezing that down with insulated glass, and how much can we get in there? And then also processes too, right? I mean, one of the things that we need are better tools, and there's a lot of people working on this right now, and there are things developing, but better tools for evaluating embodied carbon in materials and assemblies. And this is LCA work. And then the costing part of it, needs to be in a life cycle context, and that's life cycle costing assessment. So materials and processes are a big deal to me. Root innovation practice in materials and process. That's always been where I start a design problem, and especially if I'm stuck in a design problem, I look to materials to drive the creative process. And that has been amply demonstrated by the teams today working with these terracotta materials. Deep design is informed by material and process. And the thing that is alarming to me, as both a practitioner and an educator, is the educational system for our designers, for our architects, in my opinion, and my observation is not very robust here when it comes to an understanding of materials and processes. And I think that's something that we need to work on. It's something that my colleague Sanjeev Tanka and I are working on at USC with a facade educational program that we've got in the works there. Material and product trends, all right? Just quick look at these, you know, I mean, advanced glazings. We know about these vacuum insulated panels, building integrated photovoltaics. We've been hearing about that for a long time, not a whole lot of development or implementation there. Formable materials. I talked a little bit about this already, terracotta being one of these. The metallic stainless steel, copper, bronze, and more we're seeing in the building skin. Think of, you know, the screen system on the African American Museum in DC. Even silicone and silicone joints. I mean, there is significant room for innovation in the most mundane of seeming, you know, materials and processes. Curtain wall assemblies, we need significant developments there, particularly with the framing and the thermal performance of the framing with thermal breaks and this kind of thing. So it's important to ask the right questions, right? So revisiting these materials, a question that too often doesn't get asked when we look at these materials is, what about durability? You know, that question has been asked and answered with the terracotta material, which is really cool, but in a lot of cases it hasn't been, right? So as an example, let's take a quick look at the insulated glass unit. You have these materials here in the facade system. In the insulated glass unit, you've got glass, and whatever your spacer is, oftentimes it's aluminum. You know, increasingly that's being replaced by warm edge spacers. But you have these materials of basically float glass and aluminum. Float glass is an amazing material, right? In addition to its transparency, it is essentially infinitely recyclable. And it has a durability in the building skin that is indefinite, right? I mean, it's until it's broken, it's there. So what we do to compensate for the weaknesses that we're familiar with in glass, right? It's a poor thermal and acoustical insulator. It has a strange behavior with breakage. You know, so we develop the insulated glass unit, right? And we take this material that that is infinitely recyclable and just incredibly durable. We make the IGU, we collapse that durability down to a 20, 30-year time frame. We make it not recyclable in the process, and we call it high performance glazing. This is one of the problems with the nomenclature that we use again, right? We're not considering durability, obviously, or we wouldn't call that high performance glazing, right? So let's see here. Okay, there we go. So, you know, and this is a conceptual exercise that I did myself, and I hold this as an example, only of letting constraints drive you to places that you wouldn't ordinarily go, right? So, you know, I did a paper on this. It's just conceptual. It's not intended to be developed for an actual product, but, you know, trying to force myself to get my head around, you know, if I'm going to do a product that is going to be have the kind of durability that I'm looking for, if it's going to be fully recyclable, you can't be doing low E coatings. You know, it's got to be disassemblable. And, you know, the constraints drove the design here, right? So this is basically an IGU that you can take apart, and it's not a sealed cavity IGU, right? Which also eliminates the problem of the oil canning of the glass because of the differential pressure. It ended up having some interesting advantages. I called it the MILLENNIUM IGU because I was initially going after an IGU that would last for 100 years. And once you solve that problem, you know, you realize that, you know, 100 years, it doesn't matter, it can keep going, right? So I called it the MILLENNIUM IGU. And, you know, the idea is to design facade systems and assemblies in the facade systems that, if we don't have the economic wherewithal 20, 30, 40 years down into the line, our buildings are still going to be there. We've got buildings that have been poor performers from day one in the New York environment, for example, that are badly in need of facade renovation and don't get it because the process is so costly and disruptive, right? So we need to really think about this and make this easily accommodated, because these haven't happened during the past decade in New York City in good economic times, right? So we don't want to burden future generations with bad designs. That's going to be a problem. So this embodied carbon thing, this is, like I said, we're becoming increasingly familiar with this. It was unfamiliar to many people 10 years ago. The last 5 years, we've seen a lot of focus on this. And with, the nearly 40% of carbon emissions that come out of the building sector, 11% of those are from building materials and construction. Now, the nuance to this is what is referred to sometimes as the time value of carbon. And if you look at this graph here, you see the yellow is embodied carbon and the blue is operational carbon. And you can see how the effect of that embodied carbon and how it's front loaded. So 74% of the carbon that is represented in this graph here is achieved by 2030, is included in this 2030. So the operational part pays off over a long period of time. Our focus has got to be on the near term. This is what this IPCC report is telling us. We have even less time than we thought we did to get this under control. So our focus has really got to be on carbon, and embodied carbon is a big part of this. So it's pretty simple, right? Embodied carbon plus operational carbon equal whole building life cycle carbon. Pretty simple. This is my contribution to higher mathematics here, right? It's like E equals MC squared. But it does change everything, right? And why? Because, this is interesting to me, because during most of my career doing, facade on the construction, design and build, right? So we totally ignored the OC part, right? And as we were working on improving the EC part, the EC part, we were working on the OC part, right? The occupational carbon, we ignored the embodied carbon. And the embodied carbon is front-loaded, material-driven. The operational carbon is distributed over the life cycle of the building and gradually offsets the initial embodied carbon load. This time value of carbon, makes it critical that we understand this and focus on this. And this is a big problem when you're on a mad building streak like we are. Like we have been over the past decade. So, the design practices that I'm talking about have improved operational carbon by adding complexity and materiality while ignoring the embodied carbon impact. So we just completely left that part of the equation off the table, and we would build, double skin facade systems with significantly amplified materiality to achieve this, operational carbon performance. It was a big oversight. I wonder what other oversights we're currently making. So, the conventional wisdom at the time was the embodied carbon was less than 10% of whole building life cycle carbon. I suspect that this may never have been true. More recent research indicates that it's oftentimes 50 to 60%, sometimes even higher, depending on a variety of circumstances. My research has been sort of at the center of resilience, preservation, and building science, and it's really focused me on this issue of durability. And when we start talking about service life, material and embodied carbon, material selection and extended service life are the most effective means of reducing embodied carbon footprint, right? So if you extend the service life of, a building or a building assembly, if you double that service life, you essentially have the embodied carbon. So service life is a really critical factor. It's something that we haven't talked about. I've been involved in, LEED platinum building projects that did not even define the service life for the building. And there's no again, no convergence on how long a building should last or how long the facade system should last. I did some research on this, and for the buildings, it's everywhere from 15 to 30 years at the low end to Anthony Wood with the Council for Tall Buildings and Urban Habitat. They should last indefinitely until we're done with them, and that's where, you know, I vote for that. Facade systems from 20 years to, you know, more curtain wall specific, a 50-year design life. You know, some research, this was from a recent forum that we had at Facade Tectonics on the typical building renewal cycles of the major systems in a building. And this is not curtain wall specific. The curtain wall is closer to the wall. It's somewhere between windows and walls. It's closer to the wall, which is like approaching 80 years. And we've got curtain wall systems in New York City that have been in place for 60, 70 years. And they were never designed or intended to be in place that long. And the reason that they have been in place that long is because the original design fails to anticipate the need for future maintenance, repair, and retrofit to prevent obsolescence and a failure to accommodate these processes. So it's very difficult to renovate these buildings. And this is in a context of where we are expecting the global building stock to double by 2060. And, you know, that's the equivalent of constructing a whole new New York City every month for the next 40 years. So that's pretty mind-boggling. And it raises the question, are we busy building tomorrow's problems today? And, you know, my answer is unfortunately, yes, I think we are. I look at the disabilities that are around durability, adaptability, repairability, maintainability, upgradability, recyclability. These are not, unfortunately, integrated into contemporary facade system design. I took a quick look at a vanilla curtain wall system and the embodied carbon makeup. And no surprise, 93% is aluminum and glass, right? In the embodied carbon content of that assembly. What's, I think, striking about this is that, you know, aluminum and glass are both very long-lived materials, right? You could go for hundreds of years if they're properly maintained, right? And what limits this, what compromises this durability is these minority materials. It's the 7% of materials. It's the gasketry and the sealants that are what limit that durability. So, you know, if we design systems where those can be upgraded, we can look at a graph like this, where the service life is indefinitely extended. We don't even have to talk about service life. We can actually, these systems will keep going as long as we want them to keep going. We just maintain them periodically and cyclically, and we design for that. And if we do that, we're going to design very different systems than we do now. Some of you will recognize a stack joint on the left-hand side here. And this is an upper unit sitting down over a lower unit. And the blade that reaches up inside the upper unit here. This is the business end of the curtain wall system, the air and weather seal. And when we install this thing, it's the last chance we get to even to see it. We can't inspect it, much less repair it. So, you know, a very different way that we would design the facade system with these kind of drivers. And basically what I've also observed and concluded is that our facade systems lack adaptive capacity, which is a concept that comes from resilient science that's been picked up by the business world in this quote from Price Waterhouse here. And then if we look at other facade futures issues, I think what we see coming at us is I'm rooting for this, and I expect it is some significant disruption over the next 5 to 10 years. My crystal ball is as muddy as anybody else's, but, you know, and I can't tell exactly when, but I'm confident that 10 years from now, facade systems are going to look significantly different than they do now. I think we're going to rediscover the value of opacity in the building skin. And we're going to move towards more plug and play facade systems that are much more adaptable, easily changeable. Climate change is one thing, social change is another, and social change is accelerating too. And these systems need to be very responsive to these changing conditions of use. Disassemblable assemblies, right? That's the MILLENNIUM IGU. We're not bonding things together. We're making them so that we can take them apart and reuse them, repurpose them, maintain them as long as possible. Mega panel systems are trending, in places where performance mandates are stepping up. We're seeing mega panel systems emerge, which have higher areas of opacity, large panel systems with a lot of insulation being used in passive house applications and this kind of thing, with punch windows included in the assembly. And then we already talked about novel delivery methods, and supply chain management are critical issues today. So, this is the thing. Stop building tomorrow's problems today with contemporary curtain wall practices. Short strategies for doing this. Base material selection on life cycle carbon, design for the ages, maximize adaptive capacity, design for the disabilities, design to realize the full life cycle durability potential of all materials utilized. That's a challenge. That's a constraint that will drive change in your design. Minimize use of high embodied carbon materials and embrace the constraints. So yeah, the buildings that we produce today will ultimately be judged on how well they serve humanity in surviving the climate catastrophe through upcoming decades and centuries. Think about this. All of us as designers need to think about this as we do this design work that we're doing today. Innovation collaboration are intimately linked. Professional academic industry R&D collaborations hold tremendous potential. And I am blown away by what I've seen today with ACAW and what these teams have done, what these players have done. I want to extend my personal congratulations and the congratulations on behalf of the Facades Tectonic Institute. I think this is really a model that can drive change in our industry. I celebrate it. We have the Skins newsletter at Facades Tectonics. This is our April issue, which focused on R&D and innovation in building skins, on research, right? And Ayla Aksamija, who is chairs our education committee and who is our current vice president and will be the next president of the Institute. She guest edited this issue, and this is her book, which was just recently published, which is about integrating research in professional practice. So we're going to do an issue of skins. Omar and the Boston Valley guys, John, don't know this yet, but we're going to do a future issue very soon on skins and feature the work that's been done by these groups, because it's amazing stuff. So real quick, I want to tell you just a little bit about the Facades Tectonic Institute. We are a nonprofit, mission-driven organization, all about accelerating change in the built environment towards these resilience and sustainability goals. We have a lot of ways to get involved. We have a bunch of committees. We have a lot of really amazing people that are involved. We've got this Honors and Awards Committee here, and we've got the Vitruvian Honors and Awards event coming up in December. And right now we have an open submittal process underway for these awards. And I expect to see some terracotta submissions here, right? Projects involving terracotta. Really look forward to seeing that. We do events. We have a World Congress. Our next World Congress is in 2022. If you're at all interested, I know there are some facade geeks out there, right? So, and there is a latent facade geek in many of you. So, we're all about mobilizing your inner facade geek and getting involved in this stuff, and making that commitment to accelerating change in the built environment. So that's me. I'd love to hear from you about anything, and I'm done. Thank you, Omar. Thank you, Boston Valley Terracotta. Thanks to all the organizers and all of the team players and all of the people that were involved in these collaborations. I cannot tell you how impressed I am. Just fantastic stuff.
Mick, thanks so much. That was super and really kind of, laid out an incredible argument for us, which we have been really exploring. And you can see that in the work. I think back, when we started with terracotta, the initial interest was so much on, what this material does. It was still unclear because the rain screen facades were rather banal, and there was this notion that, well, okay, what's the big deal here? And so I recall at that time it was just about innovating and having more fun, and the ornament was back. And I would say in the last 2 sessions of ACAW, maybe even the last 3 sessions, embodied energy has really, that's what the firms come. They say, well, embodied energy, that's what got me into thinking about this material. And John Neary, I think, did a very lovely job of showing just how that one component and replacing it with terracotta opens this up. I think your question of durability is a really interesting one. And, we always, at least historically, architecture durability, Fermitas was always sort of part of our thinking. And I think that has shifted with the modern movement and perhaps a lot about just the disposability of things. But you open up a real interesting question, because there are a few questions that really ask, hey, what about all these LEED approved buildings, all these amazingly sustainable buildings that we have been looking at in the last maybe 20 years? Have we just been doing it completely wrong? And are we, because of the climate catastrophe, as you describe it, that we really almost have to start from basic principles again? Yeah,
increasingly, as I think about this, I'm challenging the ethics of what we're doing, and I think to a large extent that you're right, Omar, that we do need to go back to basic principles, that we do need to reinvestigate. I know a controversial statement when I say our buildings are killing us, but they are, and this is our business, right? It's painful to to have to say that and to acknowledge that, but it's true. It's happening. We're seeing it, and it's bringing change to this industry is very difficult. I talk with a lot of people about it. A lot of the problem, a lot of the finger pointing goes towards building owners, and I understand that, but we can't accept that, right? We have to take responsibility even for that. We have to get to the point of where we've got to be able to say no to the building owners and no to these building projects that don't support some kind of a baseline that we as an industry determine. I don't care what the codes say. We have to define what it is. We know what's important. We know how to do it. We can go there. We just can't listen to anybody else. We've got to make it happen. And I don't know how to do that. Really, if we were a rational society right now, we would have a moratorium on buildings. And that's an absolute non-starter. I know that's not going to go anywhere. But maybe we start with, the pandemic taught us this differentiation between essential workers and non-essential workers. So maybe we really start looking harder at essential and non-essential buildings, because by far the most sustainable and greenest buildings today are the ones that go unbuilt, right? And to the extent that they do get built, we ought to really put pressure on them being smaller and as minimal as possible. And even with the facade system renovations that we do, the ones that get done, they get done for rebranding purposes, right? And they're very carbon intensive typically, and we should be looking at these things as what is the most minimal intervention that we can make to increase the performative aspects of the facade system, right? And that's not what we're doing.
Mick, thanks so much. It was so engaging, and thanks again for the invitation that you're giving us. We'd love to sort of engage facade tectonics in the future. I do think there's, as you say, we're all facade geeks here, and there's a real opportunity here to sort of maybe start a conversation on materiality specifically and focus on that as a kind of starting point for a lot of this work.
Yeah, and just in closing, Omar, I just want to say again that, you guys have set such an example to the industry. I think we really need to hold it up. I mean, I'm so impressed with what Boston Valley Terracotta has done and what you have done, and all of you in this collaboration in terms of highlighting this material, which is, like you say, low embodied carbon, very durable material, really interesting material. We need to get this kind of activity to happen across the industry. So hopefully we can make that happen. Whatever we can do as a platform for facade tectonics, we will do it.
Great. Thanks a lot, Mick.
All right, Omar.
So
Thank
much.
you, everybody.
Yep.